Project Management Institute, Agile Practice Guide, summarized and read by Uday C. Santakumar. Section 3, Life Cycle Selection. Projects come in many shapes and there are a variety of ways to undertake them. Project teams need awareness of the characteristics and the options available to select the approach most likely to be successful for the situation. This practice guide refers to 4 types of life cycles defined as follows. Predictive life cycle, a more traditional approach with the bulk of the planning occurs upfront, then executing in a single pass, a sequential process. Iterative life cycle, an approach that allows feedback for unfinished work to improve and modify that work. Incremental life cycle, an approach that provides finished deliverables that the customer may be able to use immediately. Agile life cycle, an approach that is both iterative and incremental to refine work items and deliver frequently. In addition to that, this section also discusses on hybrid life cycles, mixing agile approaches, and tailoring factors. Characteristics of project life cycles. Table as shown summarizes the characteristics of the 4 life cycle categories covered in this practice guide. For a predictive approach, requirements are fixed, activities are performed once for the entire project, deliveries are made as a single delivery, and the goal is to manage cost. In an iterative approach, requirements are dynamic, activities are repeated until correct, delivery is a single delivery, correctness of solution being the primary goal. In an incremental approach, requirements are again dynamic, activities are performed once for a given increment, deliveries are frequent deliveries, and the goal in this case is speed of delivery. In an agile approaches, requirements are still dynamic, activities are repeated until correct, deliveries are handled as frequent small deliveries, and goal in this case would be customer value via frequent deliveries and feedback. It is important to note that all projects have these characteristics. No project is completely devoid of considerations around requirements, delivery, change, and goals. A project's inherent characteristics determine which life cycle is the best fit for that project. No life cycle can be perfect for all projects. Instead, each project finds a spot on the continuum that provides an optimum balance of characteristics for its context. Specifically, predictive life cycles take advantage of things that are known and proven. This reduces uncertainty and complexity, allows team to segment work into sequence of predictable groupings. Iterative life cycle allows feedback on partially completed or unfinished work to improve and modify that work. Incremental life cycle provides finished deliverable that the customer may be able to use immediately. Agile life cycle leverages both the aspects of iterative and incremental characteristics. When team uses agile approaches, they iterate over the product to create finished deliverable. The team gains early feedback and provides customer visibility, confidence, and control of the product. Because the team can release earlier, the project may provide an earlier return on investment because the team delivers the highest value work first. Another way to understand how project lifecycle vary is by using a continuum ranging from predictive lifecycle on one end to agile lifecycle on the other end, with more iterative and incremental cycles in the middle. The table shown on this slide is a reference from Appendix 3 of PMBOK Guide 6th edition, displaying the continuum as a flat line. This view emphasizes the shifting of project characteristics from one end to the other. Another way to visualize the continuum is with a 2-dimensional square as shown in the figure 3-1 in page number 19 of this guide. Before moving forward with this guide, let's take a look at the continuum of project lifecycle as described by PMBOK Guide on page number 665. To understand the application of the process in adaptive projects, the continuum project lifecycle should be defined. The PMBOK Guide describes the project lifecycle as the series of phases that a project passes through from its start to its completion. Within a project lifecycle, there are generally one or more phases that are associated with the development of the product, service, or result. These are called development life cycle. Development life cycles can be predictive, in other words, plan-driven, adaptive, in other words, agile, iterative, incremental, or a hybrid. The table shows the various way in which requirements and the plans are handled, how risk and cost are managed, schedule considerations, and how the involvement of key stakeholder is handled depending on the type of lifecycle being employed. Predictive project lifecycles are characterized by an emphasis on the specification of requirement and detailed planning during the beginning phase of a project. Detailed plans based on known requirements and constraints may reduce risk and cost. Milestones for key stakeholders' involvement are also planned. As execution of the detailed plan progresses, the monitoring and controlling process focuses on constraining change that might impact the scope, schedule, or budget. Highly adaptive or agile lifecycle of a projects are characterized by progressive elaboration of requirement based on short iterative planning and executing cycles. Risk and cost are reduced by progressive evolution of initial plans. Key stakeholders are continuously involved and provides frequent feedback which enables responding to changes more quickly and also leads to better quality. The following considerations apply to the center of lifecycle continuum. First, risk and cost are reduced by iterative evaluation of initial plans. And secondly, key stakeholders have more opportunities to be involved in incremental, iterative, and agile cycles than stakeholders at the project milestones of highly predictive life cycles. Project life cycles in the center of lifecycle continuum tends to align more closely with the predictive side or the agile side of the continuum depending on the way requirements are specified, how risk and cost are handled, and the nature of key stakeholder involvement. Projects in this part of the continuum may utilize hybrid project methods. It should be emphasized that the development life cycles are complex and multidimensional. Often, the different phases in a given project employ different life cycle, just as distinct projects within a given program may each be executed differently. Planning is always there. A key thing to remember about life cycle is that each of them share the element of planning. What differentiates a life cycle is not whether planning is done, but rather how much planning is done and when. At the predictive end of the continuum, the plan drives the work. As much planning as is possible is performed upfront. Requirements are identified in as much detail as possible. The team estimates when they can deliver which deliverables and perform comprehensive procurement activities. In iterative approaches, prototypes and proofs are also planned, but the outputs are intended to modify the plan created in the beginning. Earlier reviews of unfinished work help inform the future project work. Meanwhile, incremental initiative plan to deliver successive subset of the overall project. Teams may plan several successive deliveries in advance or only one at a time. The deliveries inform the future project work. Agile projects also plan. The key difference is that the team plans and replans as more information becomes available from review of frequent deliveries. Regardless of the project lifecycle, the project requires planning. Characteristics of predictive lifecycle. Predictive lifecycle expects to take advantage of high certainty around firm requirement, a stable team, and low risk. As a result, project activities often execute in a serial manner as shown in figure 3-2 on page number 21. In order to achieve this approach, the team requires detailed plans to know what to deliver and how. These projects succeed when other potential changes are restricted. For example, requirements changes, project team members change what the team delivers. Team leaders aim to minimize change for the predictive project. When the team creates detailed requirements and plans at the beginning of the project, they can articulate the constraints. The team can then use those constraints to manage risk and cost. As the team progresses through the detailed plan, they monitor and control changes that might affect the scope, schedule, or budget. By emphasizing a departmentally efficient, serialized sequence of work, predictive projects do not typically deliver business value until the end of the project. If the predictive project encounters changes or disagreements with the requirement, or if the technological solution is no longer straightforward, the predictive project will incur unanticipated costs. Characteristics of iterative lifecycle. Iterative life cycles improve the product or result through a successive prototype or proofs of concept. Each new prototype yields new stakeholder feedback and team insights. Then the team incorporates the new information by repeating one or more project activities in the next cycle. Team may use time boxing on a given iteration for a few weeks, gather insights, and then rework the activity based on those insights. In that way, iterations help identify and reduce uncertainty in the project. Projects benefit from the life cycle when complexity is high, when project incurs frequent changes, or when the scope is subjected to differing stakeholders' view of the desired final product. Iterative life cycles may take longer because they optimize for learning rather than the speed of delivery. Figure 3-3 on page number 21 illustrates some element of an iterative project life cycle for a single product delivery. Characteristics of incremental life cycle. Some projects optimize for speed of delivery. Many businesses and initiatives cannot afford to wait for everything to be completed. In these cases, customers are willing to receive a subset of an overall solution. This frequent delivery of smaller deliverables is called an incremental life cycle. See figure 3-4 on page number 22. Incremental life cycle optimizes work for delivering value to sponsors or customers more often than a single final product. Teams plan initial deliverables before beginning their work, and they begin working on that first delivery as soon as possible. Some agile projects deliver value within a day of project initiation. Others could take longer, ranging from 1 week to several weeks. As the project continues, the team may deviate from the original vision. The team can manage deviations because the team delivers value sooner. The degree of change and variation is less important than ensuring customer gets value sooner than at the end of the project. Providing a customer a single feature or a finished piece of work is an example of the incremental approach. For example, builders may want to show a finished room or floor of a building before they continue with the remainder of the building. In that case, they may complete a floor with fixtures, paint, and everything else intended for the finished floor before proceeding to the next floor. The customer is able to see and approve of the style, color, and other details, allowing adjustment to be made before further investment of time and money are made. This reduces potential rework and or customer dissatisfaction. Have you ever been involved on a project where the requirements seemed to change daily and thought, we will know the requirements when we deliver a prototype and the business approves? If so, this was a project where Agile approach could have helped. A prototype encourages feedback and a better understanding of the requirement that can be incorporated into each deliverable. Completeness and delivery are subjective. The team may need feedback on a prototype and may then choose to deliver a minimum viable product to a subset of customers. The customer's feedback helps the team to learn what they need to provide on subsequent delivery of the final finished feature. Agile teams, as a key differentiator, delivers business value often. As the product adds a broader set of features and a broader range of consumers, we say it is delivered incrementally. Characteristics of Agile lifecycle. In an Agile environment, the team expects requirement to change. The iterative and incremental approaches provide feedback to better plan the next part of the project. However, in Agile projects, incremental deliveries uncover hidden or misunderstood requirement. Figure 3-5 on page number 24 illustrates two possible ways to achieve incremental delivery so the project aligns with customer needs and can be adapted as necessary. In iteration-based Agile, team works in iterations to deliver completed features, that is, time box of equal duration. The team works on the most important features, collaborating as a team to finish it. Then the team works on the next most important feature and finishes it. The team may decide to work on a few features at a time, but the team does not address all of the work for the iteration at once. That is, does not address all the requirements followed by all of the analysis, etc. In a flow-based Agile, the team pulls features from a backlog based on its capacity to start work rather than an iteration-based schedule. The team defines its workflow with columns on a task board and manages the work in progress for each column. Each feature may take a different amount of time to finish. Teams keep work in progress sizes small to better identify issues early and reduce rework should changes be required. Without iterations to define planning and review points, the team and business stakeholders determine the most appropriate schedule for planning, product reviews, and retrospectives. Agile life cycles are those that fulfill principles of Agile Manifesto. In particular, customer satisfaction increases with early and continuous delivery of valuable products. Moreover, an incremental deliverable that is functional and provides value is the primary measure of progress. Agile lifecycle combines both iterative and incremental approaches in order to adapt to high degree of changes and deliver project value more often. Agile suitability filters. Various assessment models exist to help determine the likely fit or gaps for using agile approaches. These models assess project and organizational factors associated with adoption and suitability and then provides scores indicating alignment or potential risk areas. Appendix X3 of Agile Practice Guide, which will be discussed in a future video, provides a synthesis of popular assessment model for use as an Agile suitability filter. Characteristics of hybrid life cycles. It is not necessary to use a single approach for an entire project. Projects often combine elements of different life cycles in order to achieve certain goals. A combination of predictive, iterative, incremental, and/or agile approaches is a hybrid approach. Figure 3-6 on page number 27 depicts the basic, pure approaches to project type that combine to form a hybrid model. The early processes utilize an agile development lifecycle, which is then followed by a predictive rollout phase. This approach can be used when there is uncertainty, complexity, and risk in the development portion of the project that would benefit from an agile approach, followed by a defined, repeatable rollout phase that is appropriate to undertake in a predictive way, perhaps by a different team. An example of this approach is the development of a new high-tech product, followed by rollout and training to thousands of users. Example of a hybrid lifecycle project. A pharmaceutical company had a time-consuming United States Food and Drug Administration approval process tagged onto the end of its development process, and its entire lifecycle looked like Figure 3-6. While project teams undertook drug trials in an agile fashion, they had to present the drug to an external group to perform the FDA approval process. A consultant helped to integrate the FDA approval process portion into the agile development process to create a more streamlined hybrid approach. The short version of the story is that because FDA approval is required to be completed at the end of development process or repeated after any change, the process had to remain at the end as a separate phase. Integration using an iterative process was unsuccessful. However, the consultant created some useful quick start guides and testing protocols that shortened the final FDA approval process. Combined agile and predictive approaches. Another approach is to use a combination of agile and predictive approaches throughout the lifecycle. In figure 3-7 on page number 27, a combination of both predictive and agile approaches are used in the same project. Perhaps the team is incrementally transitioning to agile and using some approaches like short iterations, daily stand-ups, retrospective, but other aspects of the projects such as upfront estimation, work assignments, and progress tracking are still following predictive approaches. Using both predictive and agile approaches is a common scenario. It would be misleading to call the approach agile since it clearly does not fully embody the agile mindset, value, and principles. However, it would also be inaccurate to call it predictive since it is a hybrid approach. Predominantly predictive approach with some agile components. Figure 3-8 in page number 28 shows a small agile element within a chiefly predictive project. In this case, a portion of the project with uncertainty, complexity, and opportunity of scope creep is being tackled in an agile way, but the remainder of the project is being managed using predictive approaches. An example of this approach would be engineering firm that is building a facility with a new component. While the majority of the project may be routine and predictable, like many other facility projects the organization has undertaken before, this project incorporates a new roofing material. The contractor may plan for some small-scale installation trials on the ground first to determine the best installation method and to uncover issues early while there is plenty of time to solve them and incrementally improve process through experimentation and adaptation. Largely agile approach with a predictive component. Figure 3-9 on page number 28 depicts a largely agile approach with a predictive component. This approach might be used when a particular element is non-negotiable or not executable using an agile approach. Examples include integrating an external component developed by a different vendor that cannot or will not partner in a collaborative or incremental way. A single integration is required after the component is delivered. A government department had a credit insurance application development project. The multi-year project was to replace its aging underwriting system with a new, more responsive user interface and system integrations. The bulk of the project was undertaken using an agile approach with continual business input. The premium rate calculations were handed down from the Organization for Economic Cooperation and Development as a 200-page specification. The steps were clearly explained with very little opportunity for confusion and were coded up by a separate team working its way through the calculation steps. The two teams collaborated on the input variables and how to consume and display the output value, but beyond that, the calculation team worked in a largely predictive manner. When the calculation team's portion was complete, the output from the premium rate calculation were displayed on the screen and in the reports. Then the business users provided feedback on the appearance and the use of the information. The two teams ran concurrently, but had little need for interaction. Having them physically close to each other made it easier to check on the development progress, but largely they were separate sub-projects. Hybrid lifecycle as fit for purpose. Project teams may design a hybrid lifecycle based on project risks. For example, a campus construction project may have multiple buildings to improve and build. An incremental approach would focus resources on completing some buildings earlier than others, accelerating the return on investment. Each individual delivery may be sufficiently well known to benefit from a predictive lifecycle for that building alone. The goal of the project management is to produce business value in the best possible way given the current environment. It does not matter if that way is agile or predictive. The question to ask is, how can we be most successful? Is feedback needed as the team produces value? If so, increments will help. Is it necessary to manage risk as ideas are explored? If so, iterations or agile will help. When the organization cannot deliver intermediate value, agile approaches may not be useful. That is okay. Agile for the sake of agile is not the goal. The point is to select a lifecycle or a combination of life cycles that work for the project, the risk, and the culture. Agile is about customer-based delivery on frequent basis. That delivery creates feedback for the system. The team uses the feedback to plan and replan the next chunk of work. Hybrid lifecycle as transition strategy. Many teams are not able to make the switch to agile ways of working overnight. Agile techniques look and feel very different to those who are accustomed to and have been successful in a predictive environment. The larger the organization and the more moving parts, the longer it will take to transition. For that reason, it makes sense to plan a gradual transition. A gradual transition involves adding more iterative technique to improve learning and alignment among teams and stakeholders. Later, consider adding more incremental techniques to accelerate value and return on investment to sponsors. This combination of various approaches is considered a hybrid approach. Try these new techniques on a less risky project with medium to low degree of uncertainty. Then, when the organization is successful with a hybrid approach, try more complex projects that require more of those techniques to be added. This is a way to tailor the progressive hybrid transition to the organization's situation and specific risks and the team's readiness to adapt and embrace the change. Mixing agile approaches. Agile teams rarely limit their practice to one agile approach. Each project context has its own peculiarities, such as the varied mix of team members' skills and backgrounds, the various components of the product under development, and the age, scale, criticality, complexity, and regulatory constraints of the environment in which the work takes place. Agile frameworks are not customized for the team. The team may need to tailor practices to deliver value on a regular basis. Often, team practices their own special blend of Agile, even if they use a particular framework as a starting point. Blending approaches. As an example of tailoring Agile framework, one of the most common blend in the widespread use involves a coordinated use of the Scrum framework, the Kanban method, and the element of extreme programming method. Scrum provides guidance on the use of a product backlog, product owner, scrum master, and a cross-functional development team, including sprint planning, daily scrum, sprint review, and a sprint retrospective session. A Kanban board helps the team to further improve its effectiveness by visualizing the flow of work, making impediments easily visible, and allowing flow to be managed by adjusting work in process limits. In addition, extreme programming inspired engineering practices such as use of story card, continuous integration, refactoring, automated testing, and test-driven development further increases the effectiveness of the Agile team. In summary, the blend of practices from these various sources produces a synergetic result of higher performance than each individual component in isolation. Project factors that influence tailoring. Sometimes project attributes require tailoring and approach for a best fit. Table 3-2, as shown in the slide, identifies some project factors and tailoring options to consider. Demand pattern being steady or sporadic as a project factor, a tailoring option would be many teams find that using a cadence helps them demo, retrospect, and take in new work. In addition, some teams need more flexibility in their acceptance of more work. Teams can use flow-based Agile with a cadence to get the best of both worlds. Rate of process improvement required by the level of team's experience. As a project factor, the tailoring option would be retrospect more often and select improvements. The flow of work is often interrupted by various delays or impediments as a project factor. Consider making the work visible using the Kanban boards and experimenting with the limits for the various area of the work process in order to improve flow would be a good tailoring option. The quality of the product increment is poor. Consider using various test-driven development practices. This mistake-proofing discipline makes it difficult for the defects to remain undetected. More than one team is needed to build a product as a project factor. To scale from one to several Agile teams with minimal disruptions, first learn about Agile program management or formal scaling framework. Then, craft an approach that fits the project context. The project team members are inexperienced in the use of Agile approaches as a project factor. Consider starting by training team members in the fundamentals of Agile mindset and principles. If the team decides to use a specific approach, such as Scrum or Kanban, provide a workshop on that approach so the team members can learn how to use it. For additional guidance on factors that influence tailoring, see Appendix X2 on attribute that influence tailoring, which will be part of another video. And that concludes Project Management Institute Agile Practice Guide Section 3.